Those floating behemoths Matsumura had observed through his periscope were auxiliary floating dry docks, designated in American naval terminology as the AFDB series. Each one represented a triumph of engineering ambition and industrial organization that would have seemed impossible just a few years earlier. The sections that comprised these docks had been manufactured in shipyards scattered across the United States, built separately on opposite coasts, then towed across thousands of miles of open Pacific Ocean to be assembled like enormous three-dimensional puzzles made of steel. A FDB-2, one of the largest specimens in this remarkable fleet of floating repair facilities, stretched 927 feet from end to end. The structure possessed the capacity to lift 90,000 tons of dead weight, which meant it could handle even the largest battleships in the American fleet. When operating at full capacity with its complement of 600 men, the dock functioned as a complete industrial facility. It housed machine shops where workers could fabricate replacement parts for virtually any component of a warship. It contained foundries capable of casting new metal components. It operated electrical repair facilities sophisticated enough to rewire an entire ship's electrical system. Storage tanks held 65,000 gallons of fuel oil. The dock generated its own electricity through onboard power plants, distilled its own fresh water from seawater through desalination equipment, and operated with an efficiency that matched or exceeded major permanent naval shipyards back in the continental United States. What Lieutenant Commander Matsumura could not observe from his submarine, what lay beyond the reach of even the most powerful periscope, would have shattered Japanese naval doctrine even more thoroughly than what he did see. Scattered across the vast expanse of the Pacific Ocean, at coral atolls and island anchorages that had been empty water just months or years before, were 7 major advanced base sectional docks. 31 smaller auxiliary floating docks complemented these giants. The Americans had transformed every captured atoll, every seized island with a protected lagoon, into a potential equivalent of Pearl Harbor. They had taken their most precious strategic asset, their massive industrial base, and made it mobile. They had solved the tyranny of distance that should have protected Japan from the full weight of American manufacturing power. 3 weeks before the attack on Pearl Harbor, before the war between Japan and the United States had even begun, Vice Admiral Osami Nagano stood before his colleagues in a conference room at the Japanese Naval General Staff headquarters in Tokyo. The charts and calculations he presented that day formed the foundation of Japan's naval strategy for the coming conflict. Every assumption, every projection, every estimate of how long Japan could hold out against American industrial might rested on what seemed like sound mathematical reasoning. The United States possessed 8 major naval shipyards on its Pacific coast. This much Japanese intelligence knew with confidence. Mare Island in California could handle 4 capital ships undergoing simultaneous repairs. Puget Sound Naval Shipyard up in Washington state could manage 3. Pearl Harbor's facilities, being the closest American base to the war zone, could perhaps juggle 6 major repairs at once if pushed to maximum capacity. The mathematics, as presented to the admirals and staff officers gathered in that conference room, appeared favorable enough to justify the tremendous gamble Japan was about to undertake. If Japanese forces could damage or sink 20 American capital ships during the first 6 months of hostilities, and the planners believed this was achievable given Japan's superior training and doctrine, then it would take the Americans at least 18 months to repair and replace those vessels. Any ship that sustained serious damage would need to steam 3,000 miles back to the Pacific coast for repairs at one of those 8 shipyards. The journey alone consumed 2 weeks each direction, which meant a damaged vessel would be absent from the combat zone for months, even if the actual repair work proceeded quickly. This extended absence multiplied the effectiveness of every torpedo hit, every bomb strike, every successful attack that forced an American ship to withdraw for repairs. Admiral Isoroku Yamamoto, despite harboring deep reservations about initiating war with the United States, had reviewed these estimates and signed his approval. His operations officer, Commander Kameto Kuroshima, had assembled impressive charts documenting American industrial capacity in various sectors. The United States had produced 1.5 million tons of merchant shipping during the year 1941. Japan's shipyards had produced 400,000 tons of merchant shipping during that same period, which represented a significant disparity but not an insurmountable one. Naval construction operated under different constraints than merchant shipping, Kuroshima argued persuasively. Warships required specialized facilities that couldn't be quickly improvised. They needed skilled workers with years of training in techniques specific to naval architecture. They demanded specific materials, some of which were in limited supply even in a country as resource-rich as the United States. The critical bottleneck wouldn't be raw industrial power, which everyone acknowledged America possessed in abundance. The constraint would be dock space and repair facilities, physical locations where damaged ships could be lifted from the water and worked on by skilled crews. None of the planners in that Tokyo conference room, not even Yamamoto with his years of experience in the United States, had imagined that the Americans would respond by simply building new shipyards and floating them across the ocean to the battle zone. The concept lay outside their frame of reference, beyond the boundaries of what seemed possible or even rational. Shipyards were permanent installations, massive investments in concrete and steel that took decades to construct. They were geographically fixed assets, rooted to particular locations by their very nature, or so the Japanese believed. The story of how America came to possess floating dry docks capable of handling battleships actually began years before the war, rooted in commercial necessity rather than military planning. In 1927, the United States Navy commissioned its first self-propelled floating dry dock, designated YFD-2. The principle behind floating dry docks was elegantly simple, though the engineering required to implement it at scale was formidably complex. Unlike traditional dry docks carved from granite and concrete, permanently fixed to the shoreline, floating dry docks operated on basic principles of ballast and buoyancy. Pump water out of the ballast tanks and the structure rose in the water. Flood those same tanks and the dock sank lower. A ship requiring repairs could sail over a submerged dock, position itself precisely over the keel blocks, and then wait while powerful pumps expelled millions of gallons of water. As the dock rose, it lifted the vessel completely clear of the ocean, exposing the hull for repairs that would be impossible or extremely difficult to perform while the ship remained afloat. By the year 1940, with war clouds gathering over Europe and tensions rising in the Pacific, American naval planners experienced a revelation about this technology. If floating dry docks could be scaled up dramatically in size, and if they could be made sufficiently mobile to be towed across oceans, then they could eliminate geography as a limiting factor in naval warfare. Ships damaged in combat wouldn't need to steam thousands of miles back to the nearest fixed shipyard. The shipyard could come to the ships instead. The Bureau of Ships, the Navy department responsible for vessel construction and maintenance, initiated a program that seemed wildly ambitious, even by American standards of industrial audacity. The requirements were daunting. Build floating dry docks large enough to handle the largest battleships in the fleet. Design them in sections so they could be transported across oceans without requiring the world's longest tugboat tow. Engineer them to operate independently in remote locations far from any industrial infrastructure. The Advanced Base Sectional Dock program that emerged from these requirements represented American industrial organization operating at a level that would have been incomprehensible to Japan's naval planners. The construction itself was distributed across multiple shipyards, each building specific sections according to precise specifications that would allow everything to fit together perfectly despite being manufactured hundreds or thousands of miles apart. Section A of a typical advanced base dock would be constructed at Everett Pacific Shipbuilding up in Washington State. Sections B and C would come from Chicago Bridge and Iron Company's facility in California. Sections D through G would be built at Mare Island Naval Shipyard, also in California. Each individual section weighed 3,850 tons and measured 93 feet in length, 165 feet in width, and 75 feet in depth. When 10 of these massive sections were towed to a forward location and welded together, they created a floating dry dock capable of lifting an Iowa-class battleship, the largest warships in the American fleet. The engineering challenges that needed to be overcome seemed almost insurmountable when examined individually, let alone when considered as a complete package. Each section needed to be structurally strong enough to withstand the forces it would encounter during ocean transits, being towed through Pacific storms and heavy seas for weeks at a time. Yet these same sections needed to be precisely manufactured to tolerances measured in millimeters, so they could be welded to neighboring sections and form a watertight, structurally sound complete dock. The ballast systems that controlled the dock's buoyancy needed to work in perfect synchronization across all 10 sections, or the dock would tilt and potentially capsize when lifting a heavy warship. Beyond the basic structure and buoyancy control, these docks required complete machine shops capable of manufacturing virtually any replacement part a damaged warship might need, from propeller shafts weighing tons to delicate gun barrel mechanisms requiring precision machining. Commander Tamachi Hara commanded the Japanese destroyer Shipyards, and in March 1943 he witnessed American repair capabilities firsthand during combat operations near Tulagi. The experience, which he would later recount in his post-war memoir, left him deeply disturbed about the true nature of what Japan was fighting. His ship had engaged American forces and successfully planted a torpedo into the cruiser Helena, a solid hit that should have sent the American vessel limping back to a stationary dry dock for months of repairs. Japanese intelligence analysts, reviewing the damage reports and photographs, calculated that Helena would require at least 6 months in a major shipyard before she could return to combat operations. 3 weeks later, barely enough time for the ship to have steamed back to Pearl Harbor or the American West Coast, Helena appeared in reconnaissance photographs at Tulagi. She was fully operational, her guns actively firing at Japanese aircraft attempting to attack American positions. Commander Hara found himself unable to comprehend what he was seeing. Where was the dry dock that had repaired her? The reconnaissance photos showed only empty ocean and small islands without any visible infrastructure capable of handling major ship repairs. What Commander Hara didn't know, what Japanese intelligence had failed to detect, was that the Helena had been repaired by ABSD-1, the first of the advanced base sectional docks, which had been assembled at Espiritu Santo just weeks before Helena's arrival. The massive floating structure had submerged itself, allowed the 10,000-ton cruiser to position herself over the keel blocks, then lifted the entire vessel completely out of the water. Workers had repaired the 20-foot gash torn in Helena's hull by the Japanese torpedo, replaced damaged internal components, tested all systems, and returned the cruiser to full combat readiness in just 19 days. The same repair work performed at Yokosuka Naval Arsenal, Japan's premier shipyard facility, would have required a minimum of 4 months, assuming the dock space was immediately available and no other ships were ahead in the repair queue. Captain Hara's confusion reflected a fundamental conceptual gap that plagued Japanese naval planning throughout the war. Japanese military thinkers conceived of naval bases as fixed installations with permanent facilities built over decades through sustained investment. Yokosuka Naval Arsenal, the crown jewel of Japan's naval infrastructure, had been under continuous construction and expansion since 1866. It represented nearly 80 years of accumulated investment, expertise, and infrastructure development. The Americans had created equivalent capability, perhaps even superior capability in some respects, in 6 months, and then they had floated it across the Pacific to the front lines. The implications were staggering once you understood them, but understanding them required abandoning assumptions that seemed so fundamental they weren't even recognized as assumptions. Admiral Chester Nimitz, commanding American naval forces in the Pacific, understood with crystal clarity that floating dry docks had transformed the fundamental arithmetic of attrition warfare. In a memorandum to Admiral Ernest King dated January 15, 1943, Nimitz articulated this transformation with typical precision. The availability of floating dry docks in forward areas fundamentally alters the correlation of forces, he wrote. A damaged ship repaired in 3 weeks at Ulithi versus 3 months in San Francisco represents a 4-fold increase in available force strength. This wasn't hyperbole or optimistic projecting. It was straightforward mathematics. A fleet of 10 capital ships that could repair battle damage in forward locations effectively had the combat power of a 40-ship fleet that needed to steam back to the continental United States for repairs. Time and distance, which should have been Japan's greatest strategic assets in defending their conquered territories, had been neutralized by American industrial creativity. The Japanese discovered this new reality gradually, through a series of encounters that each seemed inexplicable until the larger pattern became apparent. The Battle of Santa Cruz in October 1942 had resulted in severe damage to the aircraft carrier Enterprise, one of America's most valuable assets. Japanese naval intelligence officers, examining reconnaissance photographs and damage reports, estimated the carrier would require 6 months of repair work before she could return to combat operations. Perhaps she might even be written off as too damaged to justify repair, given the extent of the visible destruction. The Enterprise reappeared in combat operations after just 30 days, having been repaired at New Caledonia by the destroyer tender Vestal, working in conjunction with advanced base repair facilities. Rear Admiral Matome Ugaki, keeping a meticulous diary throughout the war, recorded his growing frustration and bewilderment. The enemy's repair capabilities exceed our intelligence estimates by factors we cannot explain, he wrote. Ships we confirm as severely damaged return to battle before our own lightly damaged vessels complete repairs at our home dockyards. By early 1943, the United States Navy had established a comprehensive network of floating repair facilities that transformed the Pacific Ocean from a vast defensive barrier into an American maintenance highway. Advanced base sectional docks operated at Espiritu Santo, at Ulithi, at Leyte Gulf, at Manus. Smaller auxiliary floating docks serviced destroyers and submarines at dozens of additional locations scattered across the Pacific. Any American ship that sustained damage could expect to find repair facilities within a few days' steaming distance, whereas Japanese vessels often needed to limp thousands of miles back to home waters for even relatively minor repairs. The construction statistics, when examined coldly, revealed just how hopeless Japan's position had become, even if Tokyo's leadership couldn't yet bring themselves to acknowledge it. Mare Island Naval Shipyard alone, a single American facility, produced multiple complete ABSD sections while simultaneously constructing new destroyers and cruisers from the keel up. The shipyard employed 46,000 workers organized into 3 shifts that operated around the clock, 24 hours a day, 7 days a week. In just 18 months, Mare Island by itself produced more floating dry dock capacity than Japan's entire permanent dry dock infrastructure accumulated over decades. And Mare Island was just one of many American shipyards contributing to this effort. Lieutenant Commander Haruki Iki served as a naval architect at Yokosuka Arsenal, and in early 1944 he was tasked with analyzing American repair capabilities for a comprehensive assessment of Japan's strategic position. His report made for grim reading when it reached the desks of senior officers. Iki calculated that American floating dry docks deployed across the Pacific could simultaneously repair 18 capital ships, 36 cruisers, and over 100 destroyers. Japan's entire domestic repair capacity, by comparison, could handle 6 capital ships, 12 cruisers, and 40 destroyers. The disparity was crushing enough on its own, but Iki identified something even more critical in his analysis. He called it the multiplication effect of forward repair capability. A ship damaged at Leyte Gulf and repaired at nearby Ulithi returned to combat operations in 1 quarter, the time required for a ship that needed to sail all the way back to Japan for repairs. His conclusion couldn't have been starker or more devastating to Japanese hopes. "We are fighting an enemy who brings his homeland to the battlefield," Iki wrote. "We cannot sink ships faster than they repair them, and we cannot damage ships faster than they return to combat. The mathematics of attrition work entirely in their favor. The floating dry docks achieved their first spectacular public demonstration of capability during the American invasion of Kwajalein in February 1944. The battleship Maryland took direct kamikaze hits that tore a 40-foot hole in her main deck, destroying internal compartments and causing severe structural damage. Traditional naval doctrine, the accumulated wisdom of centuries of maritime warfare, would have dictated sending Maryland back to Pearl Harbor at minimum, possibly all the way to the West Coast, removing her from active combat operations for many months while she underwent repairs. Instead, Maryland sailed just 240 miles to Majuro Atoll, where AFDB-2 waited in the lagoon. The massive floating dry dock was commanded by Commander Joseph J. Rochefort, who should not be confused with the more famous Commander Joseph Rochefort, who served as an intelligence officer and played a crucial role in breaking Japanese naval codes before Midway. This Rochefort commanded one of the most valuable pieces of infrastructure in the Pacific Theatre. The dock's crew executed the repair operation with practiced efficiency that would have done credit to any permanent shipyard facility. AFDB-2 submerged its deck by flooding ballast tanks with millions of gallons of seawater, lowering the structure until its upper surface disappeared beneath the waves. Maryland carefully positioned herself over the submerged deck, using the ship's engines and rudder to maneuver into exact alignment with the keel blocks that would support her weight. Once Maryland was properly positioned, powerful pumps roared to life and began expelling water from the ballast tanks. In just 4 hours, 8 million gallons of water were pumped out, and the dock rose from the depths, lifting the 45,000-ton battleship completely clear of the ocean. Maryland's hull hung suspended above the water, every inch of her damaged plates and frames exposed to repair crews who immediately swarmed over the vessel. Captain Yoshitake Miwa commanded the Japanese submarine I-184, and he observed this operation from periscope depth, maintaining position far enough away to avoid detection while close enough to observe the proceedings. The coded radio message he transmitted to Tokyo reflected his shock at what he was witnessing. "Maryland entering floating dock at Majuro," he reported. "Extensive damage visible throughout ship's superstructure and deck. Estimate minimum 3 months repair time required, possibly longer depending on internal damage assessment." 3 weeks later, Captain Miwa encountered Maryland again, and this time she wasn't sitting helplessly in a dock. The battleship departed Majuro under her own power, making good speed, her damage completely repaired. Full combat capability apparent from observed flight operations and gun drill exercises, Miwa reported. The Americans have made time and distance irrelevant to their operations. They have solved the fundamental problem of logistics that should protect our defensive perimeter. Commander Mochitsura Hashimoto commanded the submarine I-58, and his post-war writings captured the sense of fighting against something almost supernatural that many Japanese naval officers experienced. "We would successfully attack an American carrier or battleship," he wrote. "We would observe the damage inflicted, calculate the months that would be needed for proper repairs based on our own experience with similar damage. Then we would encounter that same ship just weeks later, fully operational, launching aircraft or firing its main batteries as if our attack had never occurred. It was like fighting mythical creatures from ancient legends that could heal their wounds instantly. There was no sense of attrition, no accumulation of damage that would eventually wear down their forces. Every ship we damaged seemed to return stronger than before." AFDB-7, operating at Leyte Gulf in the Philippines, demonstrated the absolute outer limits of what these floating facilities could accomplish when it undertook repairs on the aircraft carrier Franklin after devastating kamikaze damage in March 1945. The Franklin had suffered what was arguably the most severe damage of any American aircraft carrier to survive the war. 807 sailors had died in the attack, killed by explosions, fire, and the collapse of internal structures. Smoke had poured from the carrier for hours, so thick that observers miles away thought she was doomed. Standard procedure, the conventional wisdom built up through years of naval experience, would have classified Franklin as a constructive total loss, too badly damaged to justify the resources required for repair. The ship would be towed to a safe anchorage, stripped of usable equipment and weapons, and likely scrapped. But AFDB-7 possessed a crew of 1,000 men, and that crew included specialists in virtually every aspect of ship construction and repair. They could rebuild engines, rewire electrical systems, replace structural members, fabricate custom parts for damaged equipment. The repair crews operated shift schedules that never stopped, working around the clock in what amounted to an emergency reconstruction of the carrier from the inside out. Master Chief Petty Officer William Delaney, a senior enlisted man who supervised much of the repair work, later testified before a naval board. In a stationary shipyard with full facilities and unlimited resources, Franklin's damage represented a 6-month repair job at minimum, possibly longer, he stated. We completed the work in 11 weeks while operating in a combat zone subject to potential Japanese air attack. When Franklin departed Leyte Gulf under her own power, she represented a testament to what American industrial organization could accomplish when necessity demanded it. Lieutenant Commander Sadao Kusaka flew reconnaissance missions over American bases throughout 1944, and his April report revealed the moment of strategic shock when Japanese intelligence finally understood what they were facing. Observed Ulithi anchorage in detail, he reported. Counted 6 large floating structures previously identified in earlier reconnaissance as possible cargo vessels or floating warehouses. Upon closer examination with improved optics during low-level pass, these are mobile dry docks. One currently contains Battleship Iowa, with hull completely exposed for repair work. Another appears to be preparing to receive a cruiser-class vessel. American maintenance capacity is not fixed at permanent locations, but is mobile and deployable. They bring their bases with them wherever they operate. They have made the ocean itself into their shipyard. Admiral Somu Toyoda assumed command of the combined fleet after Yamamoto's death, and he inherited the thankless task of managing Japan's increasingly hopeless naval position. At a staff meeting in May 1944, with American forces advancing steadily closer to the home islands, Toyoda presented his senior officers with the brutal arithmetic of their situation. If Americans can repair ships 3 times faster than we can, he explained, then we must sink 9 ships for every one we lose just to maintain the current force ratio. This is mathematically impossible given our current production capacity and pilot training pipeline. We are not losing this war due to lack of courage or tactical skill. We are losing to American floating steel and industrial organization made manifest in these mobile dockyards. Each section of the advanced base sectional docks included complete living quarters for the crews that operated them. Men assigned to these floating facilities didn't just work there during their shifts and then go ashore. They lived aboard the docks in berthing compartments complete with bunks, heads, showers, and recreation spaces. The docks had galleys that could prepare hot meals for hundreds of men. They had medical facilities with examining rooms and sick bays. Some even had small dental clinics. Seaman First Class Robert Leckie found himself assigned to AFDB-3 at Manus, and his letters home described daily life on what was essentially a floating industrial complex. Here we were, thousands of miles from home and civilization, living on this massive steel structure in the middle of the Pacific, he wrote. We had movie nights where films would be projected onto the dock walls when no ship was in for repairs. We played baseball games on the dock floor during maintenance periods, using the vast flat surface as an improvised diamond. We weren't just repairing ships out here. We were a floating piece of America, a slice of home that had been somehow transported to this remote corner of the world. The quality of food served on floating dry docks became legendary throughout the fleet and was a source of considerable envy among crews on combat ships. While destroyers and cruisers subsisted on monotonous diets of canned spam, powdered eggs, and whatever else could survive long Pacific voyages without refrigeration, the dry docks maintained large frozen food lockers and operated full bakeries capable of producing fresh bread daily. AFDB-2's Thanksgiving dinner in 1944 became famous throughout the fleet. The dock's cooks prepared and served 2,000 complete turkey dinners, feeding not just the dock's own crew, but also the crews of damaged ships undergoing repairs. The meal included all the traditional accompaniments, stuffing and cranberry sauce and pumpkin pie, luxuries that seemed impossible in a war zone. Vice Admiral Takeo Kurita experienced the strategic impact of American mobile repair capability during the Battle of Leyte Gulf in October 1944, arguably the largest naval battle in history. Kurita's battle plan, meticulously developed by his staff, assumed that American ships sustaining damage would need to withdraw from the combat zone for repairs, progressively weakening the American invasion force protecting the landing beaches. This assumption seemed entirely reasonable based on Japan's own experience and on traditional naval warfare principles, but it turned out to be completely wrong. Instead of withdrawing to distant repair bases, damaged American vessels simply sailed to nearby mobile repair facilities and returned to combat within days, sometimes within hours, for minor damage. Ships that Kurita's forces had observed taking hits and listing would reappear in the battle line seemingly impossibly quickly. Kurita later wrote in his post-war memoirs, trying to explain the confusion his forces experienced during the battle. "We would damage an American cruiser with shell fire or torpedo hits, observe the ship withdrawing with visible damage, assume it was eliminated from the battle for at least several weeks. Then 3 days later we would face what appeared to be the same ship, fully operational, guns firing, maneuvering at full speed. We were not just fighting the American fleet. We were fighting their entire industrial system, which they had somehow made portable and brought to our doorstep. The most remarkable pre-deployment rapid repair feat, one that predated the widespread deployment of floating dry docks but demonstrated what American repair capacity could accomplish when pushed to its limits, occurred with the carrier Yorktown after the Battle of Coral Sea and before the Battle of Midway. Yorktown had sustained severe damage at Coral Sea in early May 1942. The carrier limped into Pearl Harbor on May 27th with a list, visible damage to her flight deck, and extensive internal casualties to equipment and systems. Pearl Harbor's repair staff estimated 3 months minimum for proper repairs. Admiral Nimitz, knowing that Midway was coming and knowing he needed every available carrier, gave the repair crews 72 hours. It was an impossible deadline by any rational assessment, but somehow the workers made it happen. Yorktown entered Dry Dock No. 1 at Pearl Harbor Naval Shipyard on the morning of May 28th. 1,400 workers from the shipyard descended on the carrier like an army of ants, working around the clock in shifts that never stopped. They welded new plates over damaged sections of the flight deck. They replaced destroyed electrical cables. They patched holes in the hull. They repaired damaged boilers and got them operational again. Yorktown departed Pearl Harbor on May 30th, just 48 hours after entering the dock. Her repairs weren't perfect or complete. There were still damaged systems and jury-rigged solutions throughout the ship, but she was operational enough to fight. More importantly, she was available for the Battle of Midway, which would prove to be the turning point of the Pacific War. Japanese intelligence remained absolutely convinced that Yorktown was still sitting in Pearl Harbor under repair when Midway began. They had correctly assessed the extent of damage she sustained at Coral Sea. Their estimates of repair time required were entirely reasonable based on their own experience with similar damage. What they failed to account for was American willingness to work around the clock and accept imperfect repairs in order to get the ship back into action. When Japanese pilots at Midway reported attacking a third American carrier, Admiral Nagumo's staff couldn't believe the reports. Their intelligence clearly stated that only 2 American carriers were available in the Pacific. Lieutenant Joichi Tomonaga, in one of his final radio transmissions before dying in the battle, reported in confusion that the Americans possessed 3 carriers where Japanese calculations had indicated only 2 were possible. The presence of that third carrier, Yorktown, contributed significantly to Japan's catastrophic defeat at Midway. By mid-1944, American floating dry docks had transformed the Pacific Ocean into an American maintenance highway where distance had ceased to be a protective factor for Japan. Rear Admiral Raizo Tanaka, one of Japan's most capable destroyer squadron commanders, recognized this transformation with painful clarity. A ship damaged at Iwo Jima can be repaired at Ulithi faster than we can repair a ship damaged at Leyte and return it to Sasebo, he wrote in a report to his superiors. Think about what this means strategically. They can repair battle damage closer to the front lines faster than we can repair similar damage at our major home naval bases. We are fighting an enemy who has made geography work against us rather than for us. Between 1942 and 1945, the production statistics told a story of American industrial dominance that no amount of tactical excellence could overcome. The United States produced 7 complete advanced base sectional docks, each capable of handling battleships. They produced 31 auxiliary floating docks sized for cruisers and large destroyers. They produced 55 smaller auxiliary repair docks for submarines, patrol craft, and minor repairs. The combined lifting capacity of all these floating facilities exceeded Japan's entire permanent dry dock capacity by a factor of 4. Japan had spent decades building their naval infrastructure, and America had exceeded it in less than 3 years, with structures that could be moved wherever they were needed most. Each ABSD cost approximately $40 million to build and deploy, which represented a significant investment equivalent to the construction cost of a light cruiser. But as Rear Admiral Ben Moriel, chief of the Navy's Civil Engineer Corps, pointed out in congressional testimony, the strategic value vastly exceeded the financial cost. A single floating dry dock operating in a forward area effectively triples or quadruples our available fleet strength through reduced repair times, he explained. That makes it one of the most cost-effective investments in the entire naval program. Rear Admiral Kazo Kimura, reviewing intelligence reports on American logistics, captured the sense of inevitability that permeated Japanese naval staff by late 1944. The Americans build floating dry docks the size of city blocks and tow them across the Pacific as if they are already certain of victory, he wrote in his diary. They are not just fighting this war. They are already building the infrastructure for the peace that will follow. They plan months and years ahead while we struggle to maintain operations day to day. Chief Petty Officer Marcus Thompson worked as a hull repair specialist on AFDB-2, and his training at Mare Island had lasted 18 months before he deployed. His specialized team of 40 welders could repair torpedo damage that would have challenged the capabilities of major permanent shipyards. We became artists of destruction repair, Thompson recalled in post-war interviews. A destroyer arrives with her entire bow blown off by a torpedo. We would fabricate an entire new forward section in 5 days, weld it on, test it, and send her back to sea. A cruiser with a 20-foot gash below the waterline, that's a 3-day job. You work fast, you work precise, and you work proud because you know every hour you save means American sailors get back into the fight sooner. The medical facilities incorporated into floating dry docks added yet another layer of strategic value beyond simple ship repair. Each major dock included a hospital facility with operating rooms equipped for major surgery, recovery wards for post-operative patients, and medical staff that included trained surgeons and nurses. Dr. Lawrence Steinberg served as Chief Medical Officer on AFDB-1 throughout its deployment, and he performed over 200 major surgeries during that time. Most of his patients were sailors injured aboard damaged ships, men who might have died before reaching proper medical facilities if the floating dock hadn't been available. The dock's operating rooms were equipped to handle everything from removing shrapnel to amputating damaged limbs to repairing internal injuries from blast trauma. In November 1944, Japanese submarine E-365 received orders that reflected Tokyo's evolving understanding of what truly threatened Japan's strategic position. Instead of attacking warships, which had been traditional submarine doctrine, I-365 was directed to penetrate American anchorages and attack the floating dry docks themselves. Sink these repair facilities, the reasoning went, and perhaps the Americans would finally feel the effects of attrition that should have been degrading their fleet strength from the beginning. The submarine was detected and destroyed before reaching its target, becoming one of 6 Japanese submarines lost while attempting to attack floating repair facilities. The missions reflected correct strategic thinking.